So in this video, we're going to chat with Josh Ajima, who's a teacher in Northern Virginia. And his job is to support other teachers with their technology needs. And one of the technologies that he decided to experiment with a few years back was a 3D printer. So now his job is to help other teachers figure out ways to create solutions for their classes. And one of the tools at his disposal is a 3D printer. And he has a fascinating set of examples where he has helped educators bring 3D printing into the curriculum. And he's also very active on the web, so his website has some nice resources as well. So join us as we learn about the potential for 3D printing in education with real-life examples.
My name is Josh Ajima, and I'm an instructional technology coach at a public high school in Virginia. I work in a normal high school, but also I provide support for a magnet science academy where students from throughout my county come in to do science and mathematics research. I also do a STEM camp over the summer for 4th to 8th grade, and that's really where my introduction to 3D printing in the classroom and for instruction started was 3D printing models as part of that summer STEM camp initiative. So I do things like write for reviews for Make Magazine. I print lots of models and design lots of models for the classroom. And I present and write about 3D printing in the classroom in my blog, designmaketeach.com. Well, so much of the learning that takes place nowadays is on screen. YouTube videos and PowerPoint presentations and sort of interactive whiteboard sorts of things. What I find that 3D printing brings into the classroom is multiple means of representation. So having three-dimensional models to show and demonstrate three-dimensional concepts. The other aspect of 3D printing in the classroom is it gives students another means of representation. So students can design things that can be created and shown in the real world. And then on the Science Academy side, being able to create items for research, to research the 3D printing process, allow students to create multiple copies of something in a kind of a repeatable fashion. And really, out of all of the sort of digital fabrication tools, 3D printing really fits the scale of the classroom as far as the size, the operating costs, and the scale of objects that can be printed and developed really work well in a classroom environment. Well, I've worked with students from 4th through 12th grade, and as far as having classroom manipulatives for having objects that represent real-world things, I don't really think that there's an age limit on that. I think a kindergarten student that's able to touch and hold a model of a fossil is able to finds that just as rewarding as any other age. As far as 3D modeling, though, as far as developing and making things for 3D printing and 3D design, you can do that with first or second graders, especially if you do sort of hand drawings and digitize those. But I really find around 4th or 5th grade the ability to do 3D modeling in something like Tinkercad. It's a little bit more reasonable to happen in the classroom. Oftentimes, teachers come to me with particular problems that students are having, and particularly it can be problematic when students are asked to are given two-dimensional source materials, flat source materials for a 3D concept. And so one example is the nets of a cube. And so the Virginia Standards of Learning geometry standards had a problem involving a nets of a cube, which is a 2D representation of a folded out cube. The idea is that the students would mentally in their head be able to transform that net into a cube in their head. And so most students get that concept right away, but there's some students who just have a little bit of difficulty making that initial transformation between what they're seeing on a flat sheet of paper to a three-dimensional solid. And so I was able to create a foldable cube that printed flat that students could actually take and fold into three-dimensional space. Now, teachers have been doing that a long time with paper models, but those paper models tend to be pretty flimsy and don't always create the correct angles for students, while as the three-dimensional model that I was able to create has sort of boundaries on it so that when it's folded up, it forms the perfect shape of a cube. So I really enjoy the 6 crystal families example. That's a problem that was brought to me by a special education teacher who was working in a science classroom. The students were tasked with sort of understanding the shape and structures of crystal families. And so the only sort of material that were available for students were sort of a really hard to figure out two-dimensional representation. And so I was able to go on Thingiverse, a repository of 3D objects, and download examples of physical examples of the 6 crystal families, print those out, and in turn make enough sets of those so that each group in the classroom, each lab group in the classroom would have access to that. So this was an example of a model that not only helped the special education students, but really helped all of the students take that from a really abstract sort of concept into a hands-on laboratory setting and environment. The Fujita Scale modeling was another example where the only sort of resource available to students were a 2D representation. And in this case, thumbnails of the damage that's caused by different levels of tornadoes. And so that Fujita scale runs from an F0 to F5. And so the teacher asked me to come up with some models that would be able to show students the same house being affected by different intensities of hurricanes, or excuse me, of tornadoes. Obviously, that would be impossible to find in the real world. But what we were able to do was create a scale model in Tinkercad of a sort of an idealized house, and then progressively provide more damage to that to show the effects of the different intensities of tornadoes. And so we ended up printing 5 models showing all of those different levels, and that provided a sort of hands-on representation for the students that made it much more understandable of what that scale was trying to show. The Chesapeake Bay watershed model is a great example of creating a 3-dimensional topographic map to take the place of or supplement a 2-dimensional map. A special education teacher came to me and said her students were having trouble understanding contour lines, and that the way those contour lines represented height elevations. The students couldn't understand why water in New York would end up in the Chesapeake Bay. And so I was able to take some online data sets and assemble them together to create a map of the entire Chesapeake Bay watershed. The center example is 3D printed, but I was able to use that same data set to also create a laser cut version and a paper cut version. So these digital fabrication files that are used for 3D printing can actually be used for a variety of different tools. Now, the Howard Hughes Medical Institute's biointeractive model here is showing a protein, and how that protein changes with mutations. A biology teacher was having trouble explaining to her students how proteins fold and how these sort of lock and key structures will work with proteins. And so a 3D printed model actually does a very good job of showing how some of these changes in the folding structure of the proteins changes the overall shape. And so this particular example shows how a mutation in a protein affects the ability of a anti-cancer drug to fit in and bind to a particular site. And so in this case, the protein folds in a way that makes one cancer drug stop working while another one continues to work. And so it seems odd that this sort of a 3D printed model can represent that, but it actually does a good job of explaining how the protein folding works. And so the protein model example here, it was brought to me by a Science Olympiad team. And their task in the Science Olympiad team was to do protein modeling. So it was a protein modeling competition in which students designed a protein, but then were expected to come into the competition and from memory be able to recreate that protein. And so the protein was represented in three-dimensional space in a 3D modeling program, but having a physical model of that protein really, and the structure, really assisted students in being able to understand how the different components of that molecule came together. And so they were able to practice with the 3D printed model and then go into the competition and do the protein modeling in there. So the examples of proteins in the Howard Hughes example and the Science Olympiad example sort of lead to the NIH 3D print exchange, where it's not just K-12 educators that are doing this sort of modeling, but biologists and neuroscientists and chemists in the field are using 3D models to sort of understand structures for their research. And so the NIH 3D print exchange is a great example of a variety of researchers and people coming together to create models that are 3D printable for research use or for classroom use. For regular FDM printers, the only issue at the moment is really sort of filtering through the models and determining which ones are print well for the classroom and which ones need a more advanced sort of 3D printer to be able to create the model. The Apollo mission model was another model from Thingiverse that I printed for an aerospace educator at the Smithsonian Udvar-Hazy Air and Space Museum. And so this is an example where it's a multi-step process from sort of the launch of the mission and various stages as the components of the craft, the command service module and the lunar module and the ascent and descent components sort of come together and then back apart again. And so normally this is represented in a very sort of complex sequence diagram that hopefully you can see here. But with the 3D model, students can actually take the lander apart and sort of recreate each step of the mission and sort of understand at a more intuitive level how the shuttling of astronauts and supplies and moon rocks would go from one part of the craft to the other throughout the mission. One of the very exciting things is starting to see government agencies like NASA make more and more models available for the public. So the NASA 3D resources page is nice because it's students are able to print the lunar surface and asteroids, and so things that they'll be studying in Earth science, sort of celestial objects, they can actually have a physical connection to those through the 3D models and the 3D representations being provided from NASA itself. So in the same vein, having the Smithsonian has been publishing some of their vast supply of items. They've been 3D scanning and providing materials about those particular models. So, for instance, Lincoln's life mask here is a great example of the types of models that are available to institutions like the Smithsonian, but to be able to actually print those out while studying the Civil War is a great classroom example, and really connects to how those models were used in the past, where sort of plaster casts and a life mask of Lincoln would have gone out for admirers or people who were interested in studying the president at the time. And so 3D printing is really a modern day analog to how sort of those plaster casts and historical objects were treated. So one of the examples that I find really exciting about the use of 3D printing is in the art classroom. art classrooms can treat 3D printing as well, 3D printing is a new medium, a new tool. So I had a art teacher who was teaching a photography class, and having students do high contrast photos, talked to me about creating 3D printed lithophanes. And so the students needed to create sort of high contrast images that were suitable for 3D printing. And so we converted those and printed those out. And so students were able to look at the value, the color intensity for their prints and see how those would convert over to a new sort of medium and a new sort of art object. I'm most excited, I think, about the potential in the classroom is in the research area. And so because of the scale of 3D printing, 3D printing itself becomes a great research topic for students. So one of the first projects that students did at the Academy of Science where I work is 3D printing infill patterns to determine which particular infill pattern provided the most sort of strength to the finished product and model. Another research project that's very exciting is the vertical wind turbine project. The students who were doing this project were collaborating with students in Singapore to develop these models of vertical wind turbines. And whereas without a 3D printer, I think the students would have struggled to hand fabricate even a single example of these vertical wind turbines. With a 3D printer, they were able to print out multiple copies of each sort of variation of their design. And so in this case, they were using mathematical models to determine the blade structure of the vertical turbines. But they were able to create 3 identical copies of each design and then multiple variations on that. So I think altogether we were able to print 21 different copies of these vertical turbines blades. And then in Singapore, they were able to do the same thing by sharing back and forth the same model files. The spinal disc research project was very interesting in that the students' approach to this was to actually sort of re-engineer the 3D printer. In this case, to sort of mimic how spinal discs are actually created, the student went and printed on the axle of a motor, so the motor would spin, and so he was able to sort of create these concentric rings to build up this spinal disc. This project was great. The student went on to the Intel International Science Fair with this project, and so I'm very excited to see how his different structures that he created handle different stresses under a press. Well, to me, 3D printing is just a small part of the overall process. The key component is really the designing the three-dimensional model. So having a need and designing a solution to that need, something that solves a problem. And so Tinkercad is a great way great low-cost way to sort of get started. So you do need a computer and an internet connection, but you can start 3D modeling. It's nice to be able to have the physical model to be able to iterate off of. But the most important part once the model is designed is sharing that model. So publishing that on three-dimensional repositories like Thingiverse or Imagine, and sort of asking for feedback, writing descriptions, adding keywords, putting in screenshots. All of those things that are involved in a sharing culture are very important to this sort of 3D modeling process. Well, I think a lot of manufacturers of 3D printers are, of course, sort of looking to education as markets. So a number of different companies have sort of 3D curriculum and resources that are available on their site. And obviously, you don't need to have their model of 3D printers to take advantage of that. There's growing groups on Thingiverse, so you can search for groups that are centered around your particular education topic. And of course, I find venues like Twitter are a great place to sort of just post questions out there and sort of build an audience of people who are interested in the same sorts of things that you are. For instance, some of the things that I've done, for instance, the Virginia topographic map came about because I posted a question on Twitter and I asked for help, and someone was able to write up a tutorial for me, and I was able to follow that to create the model. Finding something that's similar to what you want to design on Thingiverse, and then writing a comment to that person. I found the educators on Thingiverse are really eager to sort of share their ideas and experiences for different models, and can often help provide guidance or help maybe customize a model that they've created for other uses. If you want to contact me on a day-to-day basis, Twitter @DesignMakeTeach is a great way. On my blog, designmaketeach.com, I have a lot of tips and tutorials and sort of how-to articles, and so they're welcome to leave a comment on a particular article. I've helped people who have left comments, and I've helped create some models for some folks who needed it. And then if you want to see just a portfolio of sort of the types of things that I'm printing on a day-to-day basis, Instagram @DesignMakeTeach is another good way to see what pops out of my printer on a daily basis.